Hello, everyone, and welcome back to another episode of Solidity Fridays. Today I'm joined with Rory and Gareth Larkin,
Up.
and we have a very special guest today, Nick Mudge. Nick Mudge is a smart contract advisor and auditor at Perfect Abstractions, and he's also the co-author of several Ethereum smart contract standards, including EIP 998 and EIP 2535, the Diamond Standard, which is what we will be focusing on today. Hi, Nick.
Sweet.
Hi. Hi, thanks for having me.
Yeah,
Well,
thanks so much for joining.
yeah. I think we'll just hand over straight to you, Nick, because we've got a lot to get through. It's such an exciting standard. So if you want to take it away, and everybody, please feel free to drop questions when you have any. And yeah, let's see where this rabbit hole takes us.
Okay, good. Sounds good. So yeah, I'm going to give a brief description of the Diamond Standard, EIP 25 Diamonds, what it is, a bit how it works, and then we're going to look at a reference implementation. This is sort of a video tutorial on the fly. So here we go. So here's the standard, and you can see that it's Diamond's multi-facet proxy. And so you might be familiar with proxy contracts. And this is the idea of you have a smart contract that points at another smart contract for its functionality. And this other contract, its code executes and affects the state variables of the proxy contract. And then the way to upgrade is you just make your proxy contract point to a different contract that has different functionality, and that's an upgrade. And so the Diamond Standard here takes that a step forward, where instead of just pointing to one contract for functionality, it actually can point to any number of different contracts for functionality. And so that opens up a door, or it opens up a whole arena of different aspects and functionality. But so I'm going to scroll down. This is the standard we're looking at here. I'm scrolling down to a picture to show a little bit more how it works. And so here's a diagram, and how a diamond works is an external function is called on a diamond. And when the external function is called, the proxy contract receives a 4-byte value, which is called a function selector. And for any smart contract, that 4-byte value tells a contract which function is being called. And so the diamond stores within its own storage a mapping from that 4-byte selector to a contract address. And so that tells a diamond, oh, this function is being called. Well, that's mapped to this address, and so I'm going to do a delegate call to that address with that function, and then that's how functionality gets executed. And so a delegate call is a special kind of external function call, where essentially the proxy, you might say, is borrowing the code from this other contract, executing the contract in the proxy's own context, executing that code on its own state variables, and basically really as if the proxy itself had that code, but it doesn't. It's just getting it from this other contract. So that's delegate call. So you can see in this diagram, function one, or func one, func two, func three, and so when func one gets called, it delegates to a particular address here. And for other functions, delegating to other addresses. And so with a diamond, you can upgrade simply for a particular function that's being called on a diamond is pointing to a particular contract, and you can change that contract address to a different contract address, and then that's how you upgrade that function or replace that function. So with diamonds, you can also add more functions, and that's simply just adding to this mapping. So you just add to the mapping a new function selector that points to a new an address. That's the guts, the heart of a diamond. How that works. The diamonds have more going on, but this is how the how the functionality is split off into different contracts. This is also, you might see how you can have unlimited functionality at a single address, because you can keep adding to this mapping of function to contract address, and so you can keep adding functions without limit.
That's great. So you can go over the size limit.
That's right. So you can go above the 24K max contract size limit. That's right. And so then that opens the door to different things. It opens the door to being able to have a single address and being able to build out a smart contract system at a single address, which has various benefits, like it makes it easier for third parties to interact with your system because it only has to deal with one address, and user interfaces only need to deal with one address. So that's some basics there, and then there's other aspects, like, because a diamond, it's really just, I'm just going to use one terminology, which is facet, and that's these contracts that the diamond is using for its functions. These are the contracts that diamond is pointing to. I'm just going to use that term facet to describe these contracts. So because a diamond only uses the code from these facets, it makes those facets reusable. So like there's a diagram here where we have diamond 1 and diamond 2, and you see diamond 1, it has inside the diamond proxy contract, it has, data A, that could be like a struct with a bunch of variables, data B, and then you have facet A. That's facet A. This is all, we're looking at what's deployed. So like diamond 1 is deployed on chain, diamond 2 is deployed, facet A is deployed. See, facet A here is deployed one time, and it has its code, and you can see diamond 1 is pointing at its code. So it's using some function or functions in facet A. And of course, when facet A's code gets executed, it modifies diamond 1's data, diamond 1's data. So you can see this on-chain facet is being used by two different diamonds. And same thing with facet B down here. So it just kind of shows you a bit of the code reuse here, on-chain code reuse, which opens up the door to on-chain facet libraries, which is something that's starting to happen more now. So then I'll also mention that before we get into code is that, so when you have a diamond, and it might have like a bunch of functions, 5 functions, 10, 20, 100, and you might want to, you'll want to know, or anyone might want to know, well, okay, here's this address. What are the functions? Like, what functions does it have, and where do those functions come from? What are the facets for those functions? And so built into the diamond standard is something called a diamond loupe. Now, just a loupe, by the way, is a special magnifying glass that's used to look at diamonds. And so that's what we call the loupe functions. Are 4 functions here that are used that are on every single diamond, and that tell you what are the functions in the diamond and where do they come from. And so this is used by tools and testing and user interfaces to show you give an address and says, boom, here's the functions on the diamond. Here's the entire ABI for the diamond. Here's the links to the verified source code of the facets where you can find functionality. And there's an application right now called looper.dev that actually does this, so you can check that out. And so that this provides transparency into the diamond. And then another thing I'll mention is that a diamond also has a standard event called diamond cut, that at any time an upgrade happens on a diamond, then this event gets emitted. And so again, that's used for tools so that it's possible to create software that shows a history of all upgrades on a diamond. And so I'll also mention in passing, a lot of people use diamonds they can use them for different things, but a common thing is that maybe you want to start a project and you don't want to deploy all your functionality right at the beginning. Maybe you want to deploy some useful functionality at the beginning and get some experience with that, get user feedback, get your feet wet, get things started, and then maybe based on how things are going and user feedback, the vote from DAOs, any number of things, you decide that, okay, we need this new functionality to be added to our system. And so then you can if it's a diamond, you can add that functionality, in a certain way. And then when you want to add more functionality, you can add more. You can replace functionality, and it can be done in a very consistent way, because the diamond, as I said, does not have a max contract size limit. So it's not like you're going to run into a limitation of how much functionality you can add. So that's often how it's used. And you can look at the standard. It goes over a lot of things. The other thing I wanted to do now is there's some reference implementations that show basically a basic implementation of a diamond which can then be built upon. It's basically an implementation of a diamond without any custom functionality. So then people can then build their applications from this base. And this reference implementation has a function that's defined in the standard called diamond cut. It's basically how you add functionality to the diamond. It has the loop functions already built into it. And yeah, and then it has some tests in it, and so it's a place to get started. But before I do that, I just want to check if there's any questions or anything else I should mention before we go look at a reference implementation.
And I noticed above that in an example there, you were using app storage as a way to store all your data. I know that there's obviously two ways to do such. Do you want to give a quick breakdown of the different ways that variables can be stored in the diamond? You get app storage, obviously, which is what I'm personally used to using. And I think, if I'm not mistaken, the other one is diamond storage. Am I correct?
Yeah, that's right. So yeah, that's great. We can go over that. So the basis for this is that the Solidity programming language, it has, if you've done any smart contract development, you can declare your state variables and you use them, and that's it. So, however, with a proxy contract that's pointing this, and I say proxy contract because this deals with diamonds or any kind of proxy contract. In the proxy contract is a contract that's pointing to other contracts for its functionality. Using the built-in Solidity storage layout, which can be like, what's that? Usually a lot of developers, they have no awareness or idea or concept of Solidity's built-in storage layout because they just use it, and it's not something. But how the data is stored in the contract is managed by Solidity. However, Solidity doesn't have support really for proxy contracts, meaning that you can make your proxy contract point to a contract, and that contract could then be writing to state variables. But in that facet or that implementation contract, you have to specify what are the state variables, and when you specify what they are, they're actually specified in a particular order, like and so in Solidity, things are stored basically at an addressing system: position 0, position 1, position 2, position 5,300,000, position 125 million, etc. Every position has a number of where something's stored, and the way Solidity does it is starts at 0 and then 1, 2, 3, and then for mappings and arrays and things, it uses random positions to store things. But so what I'm getting at here is that with a proxy contract pointing to another contract, okay, if you're just using Solidity, things are going to be stored in order 1, 2, 3, 4, 5. But now let's say you now point to a different contract. This different contract has different variables that are at 1, 2, 3, 4. Those variables are going to overwrite and collide with the state from the other contract. And so this applies so the way that in the past, very early on, the way this was handled is that, okay, you can define a struct or a contract, and you just put in all the state variables in that struct or that contract, and earlier on it's just a contract. So you just and then for any implementation contract, you always inherit that contract, and you always use the same set of state variables in the same order, so that you don't have a management problem with the state variables, things overriding each other. So with the diamonds, we've really kind of worked out a way to the programmer can handle his layout of variables without them getting clobbered. And that's what diamond storage is. That's what app storage is. So I'm just going to briefly cover diamond storage. Diamond storage is this idea of you define a struct, which you actually I have it up here, a very simple structure called diamond storage, and you put in your variables. You can put any variables you want in there. And then we have a function. Here's diamond storage, and the idea is that we're going to specify where in the proxy contract this data is going to be stored, like starting at what position. So we could start at position 100 million, and then that struct, the variables just get stored starting from that position. And so in this example, we're using a clever way to determine the position. So often you can use a unique string, like the name of your organization, and then your project, and then the particular part of your project. This very unique string, and then it'll give you a very, very unique, very specific location that's not going to collide with something else. So, but in this example here, it's using it's hashing some data here. The interface ID of ERC 1155 and the name of a name and an address and the address here. So anyway, and it gets a storage position. So anyway, so this is diamond storage. So so the idea is you have different faucets, and they are all using unique strings of where to store things. So that way they're all storing their data at different places inside a diamond. And this is important. So a faucet can define structs and data, and then it defines where that data is going to be stored in the proxy. It's important to understand that the faucet itself, no data actually gets stored in the faucet. There's no data stored in the faucet. The faucet says where the data is stored in the diamond proxy contract. And so this is important. That's why you can replace a faucet and not lose any data, because the faucets aren't storing any data. They just say where the data is stored in the diamond proxy contract, not in themselves. All right, so yes, so back what I was saying here. So yeah, so you can have different faucets, and they can say where they're storing data. You can define a struct in a file all by itself, and so a struct in a file all by itself, you can define the data and import that file into different faucets, and that way you can share the same data structure of structs in different faucets, or you can declare structs in Solidity libraries, and using internal functions, and import those Solidity libraries inside faucets. So anyway, so in other words, I'm saying is inside a faucet, you can define the structs directly in the faucets, or you could define them elsewhere and import them. Anyway, so I'm talking a lot, not showing a lot. So, I want to actually show what I'm talking. So I'm going to get into that soon. So I really started talking about diamond storage, which is, in short, is you define a struct and you define where it's going to be stored using a random location in a proxy contract. Now, for some people that might sound scary. Well, you're storing data at random places. How do you know you're not going to accidentally store two different things at the same place? Well, yeah, and the answer to that real quickly is that the address space for smart contracts is very huge. It's gigantic. It's 2 to the power of 256. And so if you're using real random locations, like with unique strings, for example, you're not going to have that chance of using two random locations that conflict. So there's not really, and if you that's actually how Solidity language itself stores data in mappings. It's how it stores arrays. It uses whatever's being stored, it hashes it and uses that. It hashes that data plus some other data to find a random location. So by using diamond storage, you're using the same mechanism Solidity uses itself in order to store data. So in other words, if you go, I don't trust diamond storage because, you know, it's risky. Well, it's just as risky as using mappings, arrays, strings, or byte arrays in Solidity. So you wouldn't want to use those either. All right, so oh yeah, so I'm talking about diamond storage, and there's something called app storage, and we'll get into that. App storage really is a special form of diamond standard of diamond storage, which is a bit more convenient and to use. So I can show that in a bit. Any other questions before I move on to looking at some code?
No, I don't think so.
Yeah, let's dig in.
All right. All right, so here we're looking at a reference implementation for diamonds, Diamond 1 Hardhat. And let's just look at it. Let's look into it. All right, so we have a diamond contract here, diamond.sol. And so this is the code for your diamond proxy contract. And so it has a fallback here, which is a main part of it. And so this is what, you know, any external function called on the diamond gets caught by the fallback. And then let's just look at it. And then so then we have a mapping here, facet address and selector position. This is your mapping from your selector to your facet address, and message sig. This is the 4-byte function selector that tells you what function. And so we're getting the facet address here, and then this assembly is just if gas efficient code that will then go ahead and do a delegate call on your facet address, which is right here. And call data copy here. So here, this is getting, your function selector plus any arguments, and it gets executed. And then, if your external function call reverts, then we go ahead and it doesn't, it fails here. That's what that is. So then it fails, then we revert and return the data, or if it's successful, then we go ahead and return the data. So then up here in the diamond, we have a constructor. So this is when you deploy your diamond, you can pass in here the contract owner, which is a security thing. They're not really part of the standard. The standard really allows you to kind of do security how you want to, but to do a reference implementation, you have to do some kind of security. So we just did a very simple security where you have a contract owner that's allowed to do upgrades on the diamond. And then you're passing in an address. This is a contract address that has the diamond cut function, which is used to do upgrades. And then this code here just creates the data structure for diamond cut. And the data structure is, okay, if you're going to add functions, I mean, you can see it right here. If you're going to add a function, you need the facet address, where the function comes from. And you're going to need, well, what you can add, replace, or remove functions. And so in this case, we want to add, so we say add. So we provide the address, the add, and then the function selectors so these are the functions from that address we want to add to the diamond. And so we create a data structure holding that data, and then we execute this diamond cut function here. And this is from a library, internal function call from a library that does the cut. So this is your constructor. So this is one place where, let's say when you're deploying a diamond, you want to store other data as well. You can expand you can add additional arguments to the constructor if you wanted to do other things when you deploy the diamond. But this is the basic of it. All right. And good. So you notice that, well, here are a couple of things here. You'll notice that, well, all right, well, we have libdiamond.diamond cut. Libdiamond here is a Solidity library. We can take a look at that. And it kind of gives an example of some basic things about diamonds. So here it is. You can see, yeah, okay, so library, Solidity library. I just want to point out that that the functions in this library are all internal functions. So here's diamond storage. Okay, well, we'll just start at the top here. We have a struct here. And this struct holds a facet address. So like when you're going to add a function to a diamond, you need to know, well, what's the facet address? Where does this function come from? Good. So you have to say, okay, what it is, and then you need to store the position. Okay, all right. So that kind of goes into the next struct here, diamond storage. So here's the mapping I talked about earlier, which is the function selector mapping to the facet address. But you know, here we're actually doing a mapping to the facet address and the selector position. So and here we have an array of selectors, and so we not only want to store, all right, the function to its address, but we're also storing the selectors in an array here. And when we're storing that array, we want to store the position of a selector in this array. And so that's why we have facet address and selector position, because we're storing for that function the address and its position in the selectors array. And the reason we're storing the selectors in this array and the position of each selector in the array is for the loop functions I talked about before, where you want to get all the functions from a diamond, and you want to get all the facet addresses from a diamond. So that's why we store store some of this data here, the selectors here, so we can be able to report what's in the diamond. So that's really this is all that's really needed to store inside the diamond for its own management of its functions is this mapping and this array. Yeah, this
Nick,
mapping here and this array. Yeah.
How does one, if someone's now adding a new function to this, let's say any facet, what's the procedure? How would they call this and add to this struct? Would it be done in a facet, or would it be done, how would that happen?
Yeah. Okay, good. Yeah. So like, yeah, how would you basically perform an upgrade?
Yes.
Like if you want to add? Yeah. Okay. I'll get into that. I know I'm getting to the minute details here. I'll get to that in a moment. I'll get to that in a moment. Good question. So anyways, but the main thing I want to show here is that right in this moment is that I'm defining a struct here, and it's called diamond storage. But like if you're creating your own facet, you know, that you want to use with diamonds, you can create your own struct with whatever name you want. But in this case, it's that, and then right below it, we're defining a diamond storage function, and this function is used to say, well, where is this struct going to be stored in the proxy contract storage? And so and we can see, okay, position is going to be stored at diamond stored position. You go, well, where's that? That's a constant up here. You can see that we have a string here, a very unique string, and we're going to hash that. And so this position here is where we're going to actually be storing the struct in the diamond. And so this pattern here can be used in other facets, in other Solidity libraries to store data in diamonds. It's the same pattern. You define your struct, you define an internal function of where to read and write that data in the proxy contract. So it's actually a very simple and small pattern here. And that's really kind of the key of like, so people ask me, well, can I get an example of diamond storage? And there is an example of diamond storage in the reference implementation, and we're looking at it right now. So this pattern can be repeated. Okay. And I'm going to talk about upgrades, but before I do that, I just want to point out that this library here, libdiamond, it has some other functions in it. But if you look at them, they're all internal. every function in here is internal. There's no external functions in here. No public functions, which is another form of external function. They're all internal. That's important because it's important to understand that Solidity libraries, and Solidity libraries defined by library here, they're very different if they just have internal functions than Solidity libraries with external functions. Solidity libraries with external functions are deployed as them independently. They're like, you have a Solidity library with external functions. That library itself gets deployed, has its own address, and it's its own separate thing from anything else. That's a Solidity library with external functions. Now, a library with only with internal functions, when these internal functions are used, by a contract, these internal functions are actually compiled and added to the bytecode of whatever contract that gets used by them. So in other words, these internal functions get added. They become basically internal functions of whatever contract or facet that uses them. They're not. So Solidity library with internal functions is not deployed as its own thing. It's deployed along with any contract or facet that uses them. So when I go back to this diamond here, and we see this, I'm not doing some here we're using here's the library. I'm not doing external function call here. This is an internal function. Basically, diamond cut here is an internal function of this contract, because library internal functions get added as internal functions of the contract that uses them. So diamond basically has diamond cut as its own internal function because it's coming from a library that has internal functions. So anyways, that's just something to understand.
Does that help with gas saving?
Well, absolutely, because internal functions cost very little gas. It's
for sure.
It's just a jump from one location to another in memory. So whereas external function calls are expensive. They cost something. I forget the exact number. Some 2,500 or something like that. Gas, something like that. So
just a question from one of the viewers. Other than saving on the contract size and not having to hit that limit, they just would like to know what are the other arguments for using a diamond standard over, let's say, a normal proxy.
Yeah. So this I'm trying to kind of go into the more of a tutorial and the technical details rather than all of the features or benefits. But there definitely are. I'd say the best place though to start finding out about that is going to this website, and there's some there's this blog post called "Answering Some Diamond Questions," and it kind of compares using a diamond versus another kind of proxy contract and some of the benefits. Like just one off the top of that. I'll just there's various things as it goes into it, but I'll just mention though that if you're going to want to develop a project incrementally, meaning it's growing over time. Most of those other proxy implementations, they're pointing to a single implementation contract, and that single implementation contract, you can you're making that bigger and bigger. It's going to hit the max contract size limit, which means that architecture you're working is going to break if you once it gets big enough. Anyway, so but that goes against, well, that's again the 24 the max contract size limit. Like he's asking, well, what are the benefits beyond that? So I'd say look at this. There's other things like fine grained upgrade. So that's another thing. So if you have a proxy contract that's pointing to one implementation contract, you want to add another function. Well, now you can go to your source code of your implementation, add that function, but now you have to deploy that entire contract again. Like you have to deploy all this code you've already deployed. And so but with a diamond, if you just want to add a single function, you can create a small contract that just has that single function, for example, and just deploy that and then add that to your diamond. In other words, so with a diamond, you just add what you need to add replace what you need to replace without having to necessarily redeploy functionality you've already deployed. So that's just another aspect of it. Okay. But anyways, I don't want to get, you can go look at that. But good. So let's look at let's answer your question about upgrades. Let's do that. So you'll notice that we have an address here. We pass in an address to a faucet, and that faucet has the diamond cut. That has the external function that that does upgrades. So, and notice that, okay, no, that's fine. Let's just go there. So we have a faucet here, and it's called diamond cut faucet. And this diamond cut faucet has our diamond cut. This is an external function. So this does the upgrades. And notice that this faucet also imports the lib diamonds and does a diamond cut. So this also kind of shows off that a good way to share functionality between really between faucets and even your diamond proxy is to use libraries, because here we're using the same library here in this faucet. So, but here you can see we go ahead and add this external function, the function calls here, and then it's merely to do an upgrade is merely to call this function, and you'll then of course have to put it in this data structure. There's an example of that. We can go to scripts here, look at the deployment. We'll just go through the deployment here. So here's the diamond cut faucet, and we deploy that. And here's now, we deploy the diamond cut faucet, but we actually, if this diamond cut function, this faucet has already been deployed in the past, we don't need to deploy again. All we need is its address. So this diamond cut faucet can be reused on chain. But in this case here, we're deploying it. We got its address. Here's the diamond, the actual proxy contract. And here we're passing, when we deploy it, we're passing in an owner address so someone can do upgrades. And here we're passing the diamond faucet address that, from the what we just deployed. Okay, so diamonds. Okay, and then we're deploying another contract called diamond init. So this has to do with when you upgrade a diamond, sometimes you might want to call another function to change any state, like set state variables or make any changes. So because sometimes when you do an upgrade, you don't just want to add, replace, remove functions. You might also want to set up some kind of state for these new functions to operate correctly. Like, for example, like say you've got a diamond, and then later on you want to add an ERC721 faucet because you want to add an ERC721 token to your diamond. Well, that might require adding like a what is it? An interface ID. There's supports interface function that tells other contracts that you now support ERC721. So anyways, you might need to add some state for that. So you could use init, diamond init, to modify some state for your diamond. And anyway, so this is covered in the diamond standard. So I'm just kind of glossing over that a little bit. And so then here we have faucet names, diamond Loupe, ownership faucet. Ownership is for changing who can own the diamond, and basically who can own the diamond can do upgrades. And then the diamond Loupe faucet, the functions that tell you what's in a diamond. And then we loop over the names of these faucets. And here, we have this cut, and this is really building up that data structure to do upgrades. And so so we're building up that. So in other words, to answer your question, to do upgrades, you create your data structure in JavaScript, and then you make your external function call in the script here. You can also, like I said, there's looper.dev. I believe that also supports making upgrades to diamonds you own. So you could even use a user interface to do this if you didn't want to use a script. So you set up your data structure, And so here we're getting a reference to the diamond and specifically to the functionality to do upgrades in the diamond. And I mean, right here is the, we're calling diamond cut. This is an external function call to cut with our data. This is an address to these two arguments are if we want to make some like changes to state during the upgrade, the address and the function to call on that address. And really, so this is really all there is to deployment. It also really gives an example of upgrades. There's more examples of upgrades in this diamond test that does tests on the diamond, but also shows examples of doing upgrades with diamond cut. Like here's one.
Awesome. So, thanks.
Yeah. So I mean, this is, yeah. So actually, this reference implementation is not very big. It has your proxy contract. It has really, it just has your ownership faucet for who can own your diamond Loupe faucet. Let me look at that real quick. And so okay, so let's do a more simpler one. Okay, faucet function selectors. So this returns to you all of the function selectors in the diamond. So this can be used to tell you what are all the functions in the diamond. And you can see the first thing we do is we call diamond storage here. This returns the struct, that has the selectors array. Because remember that when we do an upgrade, we're storing all the selectors in an array, the selectors array. And so this function returns all the function selectors. So obviously, it returns data from that array. And so here we're getting access to the diamond storage here, and then we execute this code to go ahead and return the selectors. And so let's see. So faucets here, we'll just go briefly through it. And so this one will return the faucet addresses and the selectors from each faucet. So it returns everything, so you can know where are all the functions and where they come from. And so that's what that one does. This one just returns all the function selectors. This one returns all the faucet addresses the diamond is using, just the faucet addresses. This one just returns, give it a function selector, and then it returns the faucet address that selector is using. So that's what that's doing. Okay, good. So we have diamond cut faucet that gives you your diamond cut function. That's your upgrade function. Diamond Loupe, that's our Loupe functions. We've got ownership, and so that's really the basic of the diamond. These three things are basic to any diamond, except for ownership. I mean, you could do security differently, but really these two are basic to any diamond cut faucet and diamond Loupe faucet. And they don't, like, if you're going to build a diamond, you could just, for example, use this reference implementation that just adds them to your diamond. You really don't have need to have anything to do with them, because these have already been audited and they're tested and they work, and you can just write your own application code, and really doesn't have anything to do with these two. So you can just build. And so here's we have test faucet. These are just tests, but you could go ahead and create your own faucets here with your own functionality. You're putting your vaults, your staking, your ERC721, or whatever functionality you would do there. And yeah, so we have this upgrade initializers. So this is that diamond init, which this could be contract or contracts that you call when you do an upgrade. You want to do an extra function call to modify any state, and that's where upgrade initializers is for here. And that's really what covers the reference, this reference implementation. Not a lot of code to it.
Great. Do you want to take us through the emoji?
Yeah, sure. So, okay, good. So this is a diamond emoji token. It's the idea of an ERC20 token built with a diamond, and it's called Emoji because it returns for the symbol an emoji. You know, mostly ERC20 tokens for the symbol. Let's just show it to you real quick. So symbol right here. So that usually returns some abbreviation of some ERC token. You know, but in this case, I'm not returning a you know, like USDC. That the symbol is USDC, right? And the full name might be, I don't know what the full name is, but like, so instead of returning some simple, some small name of a token, I return an emoji. In this case, it's a small diamond. So it's called, so this is the diamond emoji token. I never deployed this.
That's so great.
I never deployed this, but it's a fun idea. So this is a simple example. It uses a reference implementation. And so, okay, I'll just look at it. We'll look at the contracts. Okay, you can see it has the same directories as before. But look at the diamond here. It's unchanged. It's just like how we saw before. No need. I didn't have any need to change that. So yeah, this is a project that uses reference implementation. Okay, we just go to faucets and we can see I've added some faucets. Some 3 faucets here for various ERC20 functionality. We can go look at here. Oh, good. Okay, I'm just noticing that I'm using app storage here. Let's look at that. So we can see app storage is imported from this library file here. So we'll go look at that. All right, so app storage is a struct like any other diamond storage. App storage is diamond storage, but it's a specialized form of diamond storage that can be more convenient. And so we declare our variables. These variables are all needed to implement ERC20 and also a permits function. So we have this nonces variable. Okay, and then we have a library, lib app storage, and all it has is an internal function that says where is app storage going to be stored. And so this is where app storage is a little bit different than other diamond storage, where how it's specialized. You see how it stores and at position 0. And you know, we're not using like a unique place in storage based on unique data, like a unique string. We're saying put it at position 0, because what we're doing is we're hijacking Solidity's built-in state management. Solidity's built-in state management starts at position 0 and then stores things at regular variables and stuff at 0, 1, 2, 3, etc. For simple variables, it stores them in order starting at 0. So like integers and basically number values and like let's see, booleans, things like that, all get stored in that way. So we're sort of utilizing Solidity's built-in state management here by putting it at 0. And what that makes us able to do is, we'll go back here, is it makes us so we declare app storage S. Okay, here, so that means that we're declaring the state that struct there, which means that the struct is also going to be stored at position 0. So you know, here when we do total supply, it's starting from 0. So now one of the nice convenient things about app storage is when you do, like I use app storage even when I'm not doing diamonds and I'm doing totally like non-proxy contracts, which are just regular immutable contracts. I still use app storage because it provides a explicitness and readability to contracts, because that means that any state variable here is prefixed with s dot. So then it's very easy to see what's a state variable and, for example, what's an argument or a local variable. And so there's code readability here. So like I can see s dot allowances. I know that's a state variable. So But this also means that, well, it means that for any faucet used with my diamond, I need to declare this as the first and only variable in the faucet, so that there's no storage conflicts. Everything gets stored correctly. So I implemented ERC20 functionality. Let's look at another faucet. All right, here you can see I do the same thing here. Now these. All right, so this can be kind of confusing, which is so constructors, in faucets don't you can't in faucets you don't want to use constructors to write to state variables, because as I've said, state gets stored in a proxy contract in the diamond proxy, not in the faucets themselves. But here we're actually not storing anything to contract storage, because these are immutable variables, and these are basically constants, but they're set at deployment time. And so these are actually, so they're not being set in contract storage, they're being added to the bytecode of the faucet. So anyway, so there's a constructor here that sets these immutable variables, which are essentially constants set at deployment time. Okay, but all right. And so then, yeah, okay, we're implementing this. And mint faucet. Here again, see, app storage is always declared as the first thing. And okay, we're minting here. And if I wanted to add other functionality, some staking, I would just add another faucet. And then if I wanted to upgrade, I mean, our deployment script shows deployment, but it also really shows how to upgrade as well, because what we do is in our script for deployment, we really deploy the diamond right here. And then we go ahead and do an upgrade. So like if you want to upgrade this later, you just kind of really follow this same kind of thing here, where you just execute your diamond cut to add more faucets, more functions. Yeah, so that's that.
Is there a particular reason why you use Hardhat? I know some of your implementations have been in Foundry as well. Is there a specific one you prefer?
Oh, that I use Hardhat?
Yeah, over Foundry.
Oh yeah, I just really haven't played around with Foundry. So I know other devs like Foundry, and if it's like faster or nicer, then I think that's great. So I have no reason to use Hardhat over Foundry.
Okay, it's just what you're used to at the moment.
Yeah.
Perfect.
I mean, I might change. I started out using Truffle, then I switched to Hardhat, and I'll probably experiment, play around with Foundry sometime. And I think Foundry's, I've heard a lot of good things about Foundry, so that's great.
Okay, awesome.
Yeah. All right, and then so to show some of the transparency, we can go ahead and go to Looper. Look at some production diamonds.
Yeah, this is awesome. Loupe is quite new, hey?
Sorry, say again?
Loupe is fairly new. Is it?
One more time. Sorry,
is Loupe a fairly new development? This looper.dev?
It's been around for a while. Like,
okay.
I forget how long. Maybe 6 months or something. Yeah, but it's getting it's sort of iterative development. Like it's getting more and more capabilities over time. Like for example, right now it's supporting a lot of blockchains. I counted 27 recently.
Sure, that's awesome.
Yeah, and then so the idea here is you go ahead and put in your address, press the search button, and then it'll show that, and then it has some featured ones. So we'll just click on it. I'll click on Aavegotchi as a featured one. And so now it's going ahead and getting all the data about the Aavegotchi diamond. I don't know why it's taking so long. It doesn't have, there's no reason for it to take very long, but you know.
Must be a large diamond.
Even a large diamond can be quick, but oh no, that's too long. That's too long.
It's too long.
Let's see. Well, let's try another one real quick and see. I don't know if there's something just wrong with Loupe right now. All right.
There we go.
Okay, good. So it's showing this one. This is from Barnbridge. All right. So then you can see, okay, it's, you know, here's the address, the diamond cut faucet. Here's the function, you know, diamond loop here. Okay. And then here's its other faucets. You know, it's just barn faucet and change reward. And so anyway, so there you can see, okay, and I can click on here and that should take me to the verified source code of the faucet. Yeah, see there's the barn faucet, and then here's this verified source code. And then, you know, and then, I mean, you can see it yourself. You can read the, you know, read or write using the functions here if you have, you know, permission to do that. So that's Looper. Yeah.
It's a really cool tool.
Yeah, that's awesome.
Yeah.
Awesome. Thanks. That was amazing. Really in depth. And
Such a cool idea.
yeah, I mean, we don't have too much time to get into anything else right now, but I'm very fascinated about how this all came about and stuff. So I'm sure people can find that out somewhere online. But yeah, it's really, really awesome code. Thanks so much.
Yeah, sure. Yeah. Yeah, I mean, one thing is people ask, well, how do you organize the code? And I just thought maybe I could just show that real quick. Like here's the Avogacci. This is the Avogacci diamond, and it is a large diamond, but they just kind of separated the functionality into different faucets. Like related functionality goes into a different faucet. Okay, they have a shop faucet, so things where you can buy stuff goes into that faucet. SVG, like their graphics are on chain, and how you read that, the functions for that are in its own faucet, etc. So and then more deeper when you get into a lot of function. I mean, it's also possible, like they're not doing it here, but if this got larger, then you could have folders, and each, you know, and so each folder would represent a larger amount of functionality. Inside the folder would be faucets with smaller amounts of functionality. But that's just as briefly how you can organize it. But in this way, you could grow it pretty large and still have it organized. Yeah. Okay, that's it. I'm done on that. So, yeah.
Awesome. Thank you so much.
Yeah, welcome.
Cool. Well, thanks everyone for listening, and let us know if you have any questions we can relay to Nick, and I'm sure he'll be happy to ask and to answer them in the future. So yeah, Nick, once again, thanks so much for coming on.
Thank you for having me.